Hello everyone, welcome to a new video of Ccna tutorial. Guys, in the previous video I forgot to say you about the TCP IP model architecture. So the explanation in terms of concept, both the TCP and OSI models are the same, but as I told you before, that OSI model is totally a reference model, so means that it's not implemented practically. It's just a reference model. Reference means that people used to use this OSI model in order to explain the concepts of data communication, but practically what happens is only the TCP IP model, and the difference between OSI and TCP is that first of all, it is implemented model, so the actual communication is going to be done through the process of TCP IP, and the second is that in the first three layers of OSI model, first three above layers, application, presentation, and session, is going to be collapsed and create only one single layer, that is called application layer. Because when you're using your internet, for example, when you want to share some data, so you're not dealing actually with the conversion of the data, you're not dealing with encryption or encoding of data. For example, when you're creating your file somewhere, for example in Word, Microsoft Word, and while you are saving it, so it will directly save the data. The application itself takes the responsibility of encoding the data. So that's why practically the encoding and also the job of session layer and the presentation layer is going to be done with the help of application only. So we don't have any separate application. For example, if you want to send the data through WhatsApp for your friends, so you're just typing your message or your image, you're putting your image on the WhatsApp, and the WhatsApp is going to do the encoding parts for you and going to do the session layer and going to establish a session for you only. So you're not taking the help of another application. For example, let's say while you uploaded your application through WhatsApp and you're going to convert it with some other application for to do the job of presentation. So it's not like that. You're actually using the WhatsApp directly, not with help of another third application, or not. There's not an and practically there's no such extra layer. So the application itself is going to do for you the job of presentation and session. So practically there's only single application layer. There is no presentation and session layer, because the application itself takes the responsibility of everything. Another, for your more clearance, I will give you the next example. For example, this is your Chrome browser. It's actually an application for you, but if you want to send mail for your friends, you directly access your Gmail account. But if you see carefully, you're not, after Chrome, you're not using any other application in order to encode your data. For example, you're typing an email in ABC format, in English alphabet, but you're not using any other application in order to change that alphabet to 0101. The application, the Chrome browser itself, going to do the encoding part for you, itself going to do the establish the session for you. So if we see generally there is only single application layer, so there is no separate portions in the process of communication. So I hope it was clear why there is three single layers of OSI is collapsed in one layer in TCP IP. But the rest of the layers, transport, network, and data link, is going to do the same function. So transport is going to do the establishment of connection of ports, source ports and destination ports, and also the job of segmentation. The network is going to find the logical address of other nodes available in another network. So the rest are totally same. And the data link layer and the physical layer, since the data link layer was going to give you the information about the physical layer, so there is no need to have two separate layers, because the data link layer is totally giving information about the type of media going to be used, or the type of NIC or network interface card you have in your computer. So there is no such difference between data link layer and physical layer. It's actually the information about your physical layer. So, and it was actually a revision of previous lecture, and for today I will just give you, actually I'm not going to practically do all these protocols which today I'm going to explain for you, but it's better for you just for your basic understanding. Don't wonder if you don't know how to configure these protocols or how to use these protocols. This lecture is not for that purpose. It's just only to give you some brief information about some of the basic protocols which you will hear from me or from someone else during the networking lectures. These protocols are all application layer protocols which you are dealing with it, but you may not have that information about them. The first protocol, which is really famous between everyone, that is HTTP protocol, Hypertext Transfer Protocol. So you're daily using this. Maybe you know about that or you don't know, but it's exactly the protocol which you are accessing the web page. If you have information about, if you have a little bit knowledge of coding, guys, there will be a server or container. If you have information about the coding port, programming port, not the network port, there's a container which stores all the files, all the web pages. Maybe that web pages are in .html format or .php, whatever, or other type of web page standards. So there's a container exists in somewhere in the cloud, who used to you're using to host your website on that. For example, right now, if you want to create your website, so before creating your website, you have to buy a host name, and also you have to buy a domain name for your website. For example, you will go to GoDaddy, and from here you will buy your host, your cloud, or I can say your storage area. So you are buying your storage area here, and also you're buying a domain name for yourself, so that while you're typing www.yourdomainname.com or whatever it is. So while you have both your storage area and also your domain name, so you're uploading all of your web page files, all of your codes which you have done in Java or in PHP or whatever else language. So you're uploading all these web pages and information, servlets, GSP, if you have information about the coding. So you're uploading it in this container. Then when some user want to access this information, for example, your website name is for example abc.com, and when your user want to access your website, there is a protocol which exchange the data between, or exchange the request and response between you and your website. What is this protocol? Is that this protocol is called HTTP, or Hypertext Transfer Protocol. This is kind of like, I can say, this is kind of an agent. It's an agent which used to take your request. First of all, obviously, when you're opening your browser, you're the first one who is going to type the domain name of the website, the www.abc.com. So this HTTP is the client or the agent who used to take your request and send it to the container, or the first of all, actually, there's a process of DNS, domain name resolution. I will tell you what is that, but just for now, forget about that. This HTTP is going to take the request of you, and it will forward that request to the container, to the host. This abc.com will be a unique name, so it will look around the world, and it will find who is abc.com related to, and it will take, once it finds that it is hosted in this container, then it will take your request and send it. You know, there's a coding port or programming port, if you have knowledge of that. Then again the response will come back. So there's a request and response process, and you will see the home page or the index page of that website. So this HTTP is going to do this process for you. Then how it is going to do that? That is related to the programming, guys. If you have a knowledge of that, then it's your choice. It has HTTP request and HTTP response objects, and also depending upon the programming. But in terms of network, it's going to take the request and it will forward it to the servlet container and to server container, and it will respond it back to you. This was the job of HTTP. So everywhere which you are accessing any website, for example youtube.com, so there's a HTTP protocol who is taking your request, and this www.youtube.com means that you want to see the index file or the first home page of the youtube.com, and it will take it and it will bring you back the response of that. So now there's another protocol. Let's proceed further. That is HTTPS. So there's, in terms of communication or in terms of working principle, there's no such difference between HTTP and HTTPS. But the difference is, while you're sending the request, the HTTP will show the request format in plain text and the URL bar of that application which you are using the HTTP protocol. Let me tell you once again, HTTP is using the plain text format and HTTPS is using the encrypted format. What does it mean? It means that while you are typing, for example, while you are typing the www.youtube.com, then you are accessing something. This request will not be forwarded to the server in plain text if you're using HTTPS. So means in the middle of the communication, if there was someone who we are usually call it as man in the middle, this person cannot understand what request came from and where it wants to go. So the HTTPS will give you this facility that will encrypt your data and encrypt your request, and also it will encrypt the response, whatever coming back from the container or from the cloud. But it will decrypt it once it came to you, and you will see the plain text back again. But in duration of the connection, the communication from you to the server, the communication will be encrypted in HTTPS. But in HTTP, you will find plain text. So you will ask that how we know that the website is HTTP or the HTTPS. It depends on the person and depends on the business, actually, guys. So if some of the companies wants to have a website of secure website, they have to pay for that. You should pay some charges to get some VPNs and to get some SSL. So these are security concepts, guys. So you will understand that if you go to the security lectures. But it's your choice. So like for example, we have SSL VPN type. Other type of VPNs are available which you use to encrypt your data. Now it depends on the business. It depends on the company. If they want to have a website who should be secure, they can buy something. For example, see, Google is secure, YouTube is secure, because you can see the so they have both got their certificates. There's a certificate available here, so you will get the knowledge of this, guys. It's really advanced concept. You will get this in security studies. But there are some of the websites which they don't want to have a secure website. For example, you just browse your favorite website which you're dealing with. So type them and see if there was a see, this website is also encrypted and it's using HTTPS. But let's say for some other website, right now I am not reminding any good website who's not using the HTTPS. So you can search your usual daily websites and see whether they are using HTTP or HTTPS. The port number which HTTP is using 80. See, guys, there's a big confusion between the students that when they know about the HTTP port has 80, but they don't know what does it mean actually. When you're using your browser to access a website, it doesn't mean that this browser's source port is 80 because you're using service of HTTP. It doesn't mean that the source port of this browser, or for example, not the browser, you're using Microsoft Outlook for your mailings. Wherever you are using HTTP, it doesn't matter. It doesn't mean that you're using port 80. your source port is different than etc. Your source port will depend on the type of application you are using. For example, the company or the browser, Chrome is related to the Google company or some other companies who used to make some applications. It depends on the coding of that application, that which port this application is going to be used in background of the computer. So the source port it really doesn't matter. It depends on the application. It can be anything. But the destination port, if you're using service of HTTP, the destination port will be 80. So when in the transport layer the packet comes and it sees that the destination port is 80, so it will directly understand that this this packet is encapsulated. This is an HTTP packet, and means it's encapsulated with HTTP headers and trailers. That is source port and destination port. So this 80 means that the destination port is 80, but the source port is any port. It's a random port, so it can be anything depending upon the application. But then HTTPS, so it will use 443 for HTTPS. The next protocol, or some basic protocol, is the DNS, Domain Name Service Protocol. This is also one of the really daily useful protocol, which I don't know you heard about it or not. But let's say you want to access a website. The name of website is facebook.com. But we already said in the previous lecture that computers only deals with what? Computers only deals with numbers, and that number is the binary actually. So now you will ask me that okay sir, if the computer is dealing with binary number, then how it's possible that when you're typing here facebook.com, it will bring you the Facebook page? So here is the answer. Actually, the answer is that there's a protocol which gives the human a facility for the human being. What is that facility? You know, when I tell you that, please remember the binary number of these websites. For example, this is the binary number of Google. Let's say this is the binary number of YouTube. Binary address means that if you want to go to YouTube, you should type this in the URL of your browser, and you should remember this for Facebook. Let's say, is it really not difficult for you to remember these many binaries only for 3 websites? Now imagine right now you have so many websites in your mind. For example, you have whatsapp.com, Instagram, YouTube, Facebook, Google, GoDaddy. So many websites right now you have in your mind. But if I convert all those names in the binary number, will it be really difficult for you to remember? Obviously, it's really difficult for you to remember. So the solution for this came here. That is the DNS protocol. It's a really beautiful and it's a really lovely protocol that it will give you the ability to convert, or to, yeah, it's a really good term to use, to convert the name of a domain, the name of some destination, to number, and reversely back to name, reversely to name. What I'm saying is that it will convert the name to number and also number to name. So whenever you're typing here facebook.com or google.com, you don't think that this is the actual the HTTP will understand that this is Google. Actually, it will take the payload of or the data as a google.com in its request package. No, the HTTP will again take the 0101. But the thing is that here, before sending of the HTTP request, when the user browser is sending the request to the server, before the HTTP, it will first of all send the DNS packet, the DNS, to resolve who is google.com. It will resolve that DNS, the name of google.com, to the IP address of the google.com, and then computers itself will convert that IP address to 0101 number. So what I'm saying is that before the process of communication, just before I said you that there's one thing in between which I skipped it on that time, but right now I'm saying it, that is the DNS process. So before you're sending your request to the server, to the container, you will first resolve that who is facebook.com or who is google.com. So the DNS will solve this issue for you. Once it is solved, then later on you can use the IP address. So but if you want to, for example, here if you I will give you an example, guys. So if you see ping, you will understand what is ping actually, guys, in the later studies. Okay, we will use daily this ping. When I'm pinging www.google.com, so you will not reply again from google.com. You will see that the reply is coming from this 172.168.36. So means if you type here the same IP address, it will again switch you back to the Google website. So it's your choice whether you can use the IP address or you can use the DNS, the domain of the name of that one. For example, right now you have your own name and you have your identity number. Depending on your country, you all obviously you have an identity code, which there is a name specified there. So but people will not ask you by your number, they will ask you, they will call you by your name. It's using TCP and UDP. Guys, I think I said, yeah, and HTTP, and HTTP is the service that the transport protocol is TCP. Means it's reliable, but in DNS it's TCP and UDP. You will ask me that what's the difference now, because it's using two protocols at the same time. The difference is, guys, when the user is sending the request to the DNS server, there will be a specific server that is called DNS server, which DNS server. There will be DNS server. How do you know that what's your DNS server? You just go to type ncpa.cpl in your computer, and if you are using a Ethernet cable, I'm not right now using an Ethernet cable. I'm not using cable connection. I'm using wireless connection. So you just get there and also go to status, and you will see here that who is your DNS server. Okay, so it's not showing here. Let me check it from here. Properties and IP version 4. So it's obtained from the HTTP server. So I will tell you what is that, guys. Just wait for some time. So in your computer you have your own DNS server. Mostly people are using Google DNS server. That's 8.8.8 and also 4.4.2.2. So this is the Google DNS server. When the packet reaches, now what my point was to explain you was that when the DNS protocol is using TCP and when it's using the UDP. The first query, when the user browser in your Chrome, when you're querying for a website, for example youtube.com, the first packet which is going to be sent for the UDP, for the DNS server, is in UDP format. So the user will ask that who is youtube.com, but the packet is UDP, so it can be missed in between, so it will, you should send it back again. But in case, let's say this DNS server don't know who is youtube.com, so it doesn't mean that in entire world we have only single DNS server. There is multiple DNS servers. Every company is depending on the business, so they got to have this ownership of a DNS server. They want to host all the domain names around the world. So your first query to your first DNS server will be in UDP format. But if UDP. But if your first DNS server don't know who is youtube.com, then it will ask the other DNS servers that my client has requested me to who is youtube.com, but I don't know who is YouTube. So this DNS server will ask some other DNS servers around located in the world. So your nearest DNS server, for example, if you are accessing a website from India, so your nearest DNS server, wherever it is. So if it can respond to you, then it's fine. Otherwise, it will search for some other DNS server located somewhere else. This is the process of communication between two DNS servers as in TCP format, but the process of the first packet, the process of communication between the user and the DNS server, the first packet, is in UDP format. This was the difference, that how the DNS is using TCP and UDP at the same time. So depending upon the communication type. The other one is DHCP. dynamic host configuration protocol. This is a really useful and also it's really important protocol which daily in any organization you are using this DHCP. Once we have started with the practicals, we daily deal with IP addressing, which is a really hectic task if you do. For example, in an organization there's more than, for example, 200 PCs, and if you go, and not only PCs, there's printers, for example, access points, so many other devices are available in an organization. But if you daily go to every PC and also assign some IP address for that, then it's a really difficult task to do it daily. So the solution for this is the Tcp protocol, which you will configure a server, you will configure someone here in network. The person who is serving for us, or the computing device who is serving for us, is the server. Means the server is your helper or your waiter kind of stuff. So it's a staff. The server is going to we will configure server in such a way that you should daily, you will say to the server, you should daily assign IP address for every machine, and we will give some conditions that give some specific IP range for some PCs and give some specific IP range for some other departments. So configuration of the DHCP is I will try to have it in further studies, because right now you don't know how to even assign this statically. This process of assigning by yourself is called static IP addressing. So even right now you don't know how to assign a static, so it's a really advanced topic if I practically show you. But in the future studies we will know how to configure a server. The server can be a Microsoft server, it can be Linux server, it can be a router as a server, it can be switch as a server. We can configure so many devices as DHCP server, but mostly in organization people are using Linux or Microsoft, but 90% of people are using the Linux servers because it's more secure. So it's as I said before, this is related to the system administration. If you want to know how to configure only the servers, you don't need to deal with how the network communication is working, so you can go for system administration and the certification for the system administration like MCSA, MCSE. So the DHCP is a really good facility for the organization, which daily can assign once the device is booted. For example, your laptop is switched off, and once you switched on your laptop, it will directly request. There's a process of there's a DORA process, which we call in DHCP IP addressing. So in the DORA process means like client will ask the server to give some IP address for him, then the server will respond back to the client that, so it will like request, or it will offer offer some IP address for the client, and at first it will check that whether this IP is already assigned for someone else or not. So there's a really beautiful process between the client and server while assigning an IP address, but it's really it's using UDP. It's not that fast. It's not that reliable, but it's really fast. So you will once you started your machine, you will directly get the IP address, even you will not notice how the process of IP addressing is being assigned, but it's running on the background. So this was the DHCP protocol. It's using 67 and 68. 67 means while the client is requesting from the server, the packets coming from client to the server is in the UDP is 67, and the responses or the packets from server to client is in 68. UDP is 68. Another protocol is FTP. This is a called file transfer protocol, and it's used for uploading and downloading the data. While you are uploading some data from network, for example, you're going to Google and you're downloading some data, that data your request, for example, you're downloading, let's say you're downloading packet tracer, let's say. So right now I searched packet tracer. So see what the process is happening. So first of all, I'm going to this downloads.digitaltrends.com. Once I'm clicking this is the first process of DNS. So the first it will do the DNS resolution. See how it was fast. So you even didn't realize when the process of DNS is done. The DNS process has been done. It got the IP address of the downloads.digital.com, and it has gave this IP address to the HTTP protocol, and the HTTP protocol has access to the web page of the download. But once you press the download, now here the process of downloading will be started. So once you click the start download, then there is no process of HTTP and HTTPS. So the entire process is going to be from FTP until, see, HTTP has done its task till finding the URL of download. And right now, when I press the start download, then it will switch this URL to the FTP, and the FTP will download it back. And the same process also for uploading. When you are uploading, so please don't be confused between the process of HTTP and FTP. HTTP is accessing only till I can give as an example. For example, HTTP will reach you till the door only, but the picking up of the item is the FTP responsibility, not the HTTP responsibility. The TFTP protocol, Trivial File Transfer Protocol, is also doing the same job as FTP, but it's faster. Because it's using TCP and it's using UDP. UDP is faster, obviously, but it's not reliable. So it's possible that during the downloading you will miss some data. That's why in every website, when you are downloading some data, you will directly use FTP, because any single data, you don't want to miss any single data. But there's your choice. Sometimes you can use the TFTP. It's your choice. People are not using an organization in the TFTP. People are mostly using the FTP. Sometimes in backup recovery process, people are using this TFTP. So SMTP, Simple Mail Transfer Protocol. There's two protocols, guys. Let me explain this. SMTP and two other POP2 or POP3 and IMAP protocol. There actually there are three protocols, but I'm sequencing them as a two protocol. One is SMTP and one is POP and IMAP. In terms of their function, they are different. POP and IMAP are both the same in terms of function, but their architecture or their development is different, but their function is same. So guys, suppose this is your PC, and this is the Google server, let's say, or Gmail server, and this is, for example, your friend PC. You have your own account of gmail.com, so it's your gmail.com Gmail server. Your friend, let's say, is using for example, yahoo.com. Or it can be possible also, it also can be gmail.com. That really doesn't matter. So because there's not a single Gmail server in entire world, so depending upon your location, Google has allocated separate Gmail server for redundancy purposes. Please remember this term, redundancy or high availability, because if there is a single server, then the chances of server failure is really high, because so many requests have come at the same time, then the server will go down. So it can be multiple server. What I'm going to explain this here is, when you want to send a mail for your friend, your mail from your laptop to the Gmail server, and also downloading your mail or watching, or I can say viewing your mail from the server to your laptop, is the job of POP or IMAP. POP2, 3 or IMAP. So this POP2 or POP3 or IMAP, right now the latest protocol people are using IMAP. POP2 and POP3 is now deprecated, or I can say it's not used anymore. The job of IMAP is to upload your mail to the Google server. When you want to send your mail, the first process is to first upload your mail to your server. Then your server will send your mail to your friend wherever you want to go. So the uploading to server and also downloading while you want to view, you have got new mail in your inbox and you want to view your mail. So this is the responsibility of IMAP and POP to show the mail for you, and also to take your mail, and also pulling and pushing. I can say pushing and pulling is the job of POP and IMAP. But here, if in the same server, let's say, if in the same server your client is, let's say in the same server, your friend is, friend Gmail is related to. So there is no use of, in this architecture or in this topology, there is no use of SMTP protocol. But if your friend is, or if your friend server or mail server is in somewhere else, it really doesn't matter if it's yahoo.com or hotmail.com or again Gmail server, but not the same server which you are using. So now there is a communication between server to server. So this mail server should send your mail from this server which is related to you to that friend server, yahoo.com or other the Gmail server 1, server 2 or server 3. So this job is done with the help of SMTP. So SMTP will take the email between server and it will send and receive mails only between the server, not between server and client. Then again back once the mail received to the yahoo.com server, then it's a job of POP or IMAP back again to fetch or to push or pull the mail for you back. So this was it's using TCP 25 and POP3 is using UDP 109 and 1010, and also IMAP is using TCP 143. So how IMAP is using nowadays, because see it's reliable, it's using TCP. Yeah, so another protocol is SNMP protocol. It has 3 versions. What is the job of SNMP is it's used to monitor your network. Monitorization or monitoring. Monitoring means, for example, in an organization multiple PCs are located, or PCs, printers, servers, so many devices are connected. Between or among all of them there is one another big server actually, or one another really secret server kind of a stuff. The security for this server is really high, which is called this SNMP server. This server is also linked, joined with all the servers and all the machines and the network. So yeah, once we started creating topologies and configuring topologies, so you will understand how to create a topology, a small topology where there's 2 PC, 3 PC, but then if we create big topologies in CCNP and CCI level, so there are so many servers, printers, laptops, and among them there's one other CCNP server. The job of this server, it has one agent. Again, there's a person who is working for this server only. And each and every machines, or in each and every computers, there's another kind of agent, I can say, installed there. And each and every node or PCs located in a network, one agent is installed, or one agent exists there in your computer, which will not warm you anything. It will not warm you, or it will not pop up any message for you. It is just sitting somewhere in your PC and just observing you, what you are doing actually. All the stuff which you are doing, all the packet exchange, where you are sending some data, where you are receiving some data, or you are watching some movie, or whatever you are doing, it will not warm you anything. It will not give you any alert message that please don't do this, it's not allowed. It will not do anything. It will just watch what you are doing, and it will give this information to the main agent. There's another agent in between, where all the small agents will give the information to this agent, to the middle agent, to the single agent. So when the data came to this main agent, then this agent will going to save all those data to the SNMP server. So there's a database, obviously. So a database is there where it stores all the network messages. Yes. So it will store all the network messages in this database server. So for future reference, if something happens, let's say any data missed or any data corrupted or any hacking, maybe some attack has been done, or maybe anything data exploit, data whatever is happening, so no one can hide himself or herself to say that I have not done this task, because this is an MP server and this agent is going to take the data and it will store it in this data, and later on the administrator can see what has been done to our network. Okay, so this was the job of SNMP. In every organization, people are using this in SNMP server. So it has 3 versions: version 1 and 2, and also version 3. The difference here is that in version 3, our data is encrypted format. But in version 1 and 2, there is no encryption. But in version 2, there are some other facilities also available, like authentication. Only in version 2, authentication exists. So in CCNP, you will have the practical of SNMP, how to configure SNMP server in our network. But for a Ccna level, it's better for you to have a brief information about the SNMP. So there is nothing extra about, it's using UDP port numbers. So it was just basic information about some of the basic protocols. And I think I forgot to say one another protocol, that is Telnet and SSH, which we will daily use. This it's used for remote access, guys. Telnet is in plain text format, and SSH is in encrypted format. What I'm saying is, for example, in your network there are so many devices, and your administrator is sitting somewhere, for example, in his department, in IT department. So he wants to access some PC or some server available on some other area. I'm not saying that in the same company, for example, in the same building, it's even possible to access the server in another building, and LAN communication really doesn't matter. If you want to access the console, it will not actually. First, I should say that the Telnet and SSH will not give you the web access or the GUI access. It will not give you the GUI access of a device, whether that device is a router. We will use this, guys. Please don't be confused. Just understand that this is for remote access. We will do the practicals once we start with the practical. Telnet and SSH is part of our lecture in CCNA. For example, switch, router, switch, ASA, firewall, or any other server kind of stuff. So we will use this SSH and Telnet in order to access their console and to do some configuration. In network, all the configuration is in CLI mode. So we will configure all the devices CLI through CLI. But sometimes the device is not available with us. So for example, here our access point is configured here, and for example, right now it's not near to me. I want to do some configuration on it. I have two choices: either to go through the GUI of my access point, or through the CLI access. So if I want to go the GUI access is through HTTP and HTTPS, because we will have a browser, and from here I can access my my router or my access point, sorry. So yeah, now the GUI is accessed for me, so I can do any type of configuration if I want to do in this. But if I want to, for example, in networking, we mostly deal with CLI configuration, not the GUI. So in that case, we have to use the Telnet and SSH protocols. So there's a software called PuTTY, and once we started the practicals of Telnet and SSH, I will give you the download link and also how to use this telnet and SSH. I'm just for demonstrating you. I'm showing this 168.0.1. You can use telnet or SSH, whatever you like. For example, I'm using telnet, and telnet is using port number 23. So you are accessing. See, this is my this was the GUI access of this access point, and right now I'm accessing the through telnet, the CLI of that. So the telnet and SSH protocols are going to be used for remote access, the CLI remote access of any type of device, whether it's a server, whether it's a router, switch, firewall, anything. So we will daily use this telnet and SSH a lot, so you will never forget this, all these protocols which I have mentioned. Right now, if you are feeling that's really huge lesson for you, don't worry. Entire network we were going to deal with this protocols only. So it was a basic information about some of the basic protocols, not all the protocols. So I hope this lecture was sufficient for you and also efficient for you guys. Have a nice time. Bye bye.